Now, solving equations that require two-step process, or what we look at as two-step equations, these are equations that have a combination of more than one operation to solve. For example, let's start with this. What is the value of x? All right. The value of x in the equation make it a little darker. 8x plus 9 equals to 33, and that's the question. All right, and then you'll solve for the value. Now, when we look at two-step equations, I'm going to write the equation again. We can tell that it has two operations that we're going to use to solve it. All right. First, again, we have to get x by itself. So we remove, or we use the inverses, in this case the additive inverse, all right, to add its opposite on both sides. Plus 9, we're going to add negative 9 on both sides. All right, so we have 8x, and plus and minus cancel. So when you're solving for equations, you want to do those two procedures, or try those two techniques to get the x by itself completely. And then 33 minus 9, negative 9 minus from 33 will give you 24, excuse me. All right. And then we have another operation. We need to get x by itself completely. So we're going to use the multiplicative inverse. Okay, inverse. And we're going to divide by 8 on both sides. The 8's cancel. All right, and then we have x equals to 3. So the answer is, what is the value of x? The value of x is 3 in this case. All right, let's solve another equation, which will require multiple steps. We're going to have solve the following equation. All right. Put this back a little bit. For x. Okay, I'm gonna write this down here. I'm gonna write this down. 14 minus 2 equals to negative 3x over 8 plus 17. So we have a combination like we have, all right? So we have a combination again of multiplicative inverse and additive inverse being used. So we're going to write the equation over here just to present a clearer view of what we have. All right. Now, normally we could, before we conduct the process of using additive inverse and multiplicative inverse, let's look at like terms. If you have any like terms that you want to combine, you can do that right now. 14 minus 2 will give you 12. All right, and then we'll just continue to show that as a step-by-step process. All right. Now we can use the the whole point is to get x by itself. All right. So that means we get x by itself. We need to move a positive 17 on the other side, or to get rid of that on that side, so you have x by itself. In order to do that, we're going to use the additive inverse again. All right. So whatever our present sign we have, we're going to add its opposite. All right. So it will be a negative 17 on both sides. I'm going to use a straight line method. Negative 17 here. All right. So this 17 cancels. We don't have to put 0 because you know that 0 is 0. We'll just have 0 plus a negative 3x over 8 will still give you a negative 3x over 8. Negative 17 plus 12 will give you a negative 5. From 12, negative 17 plus 12, positive 12 will give you a negative 5. All right. Now, we have a whole negative 5 equals to negative 3x over 8. We need to get rid of the 3/8, all right, and we're going to use the multiplicative inverse. All right. Okay, we're going to use the multiplicative inverse, and this deals with multiplying the reciprocal of this value on both sides. So the reciprocal of negative 3/8 will be a negative 8/3. I'm going to do it on both sides. Alright, I'm going to do it on both sides. So this, and even the negatives, alright, they cancel. So you have a negative 5 times a negative 8/3. The negatives cancel. When you have two negatives in multiplication, you have a positive. So you have positive 40 over 3 equals to x. All right. And if you want to write it the correct way, or x equals